welcome to this lecture series on noise control in mechanical systems with myself, Professor Sneha Singh, and we have just completed the module on acoustic metamaterials and their performance for noise control and various kind of sound wave manipulation. So, this is what we have completed. So, with this controls our module, the overall topic on passive noise control. What are the various kind of devices such as the barriers, the enclosures, then the absorbers, and within the absorbers you have got porous fibrous absorbers, and you have the resonance type, and then you have these metamaterials. So, various kind of materials we have discussed and how they help in controlling the noise. So, now we will begin with what is the noise in the mechanical system, and we will see some specific cases and case studies on how these noise can be mitigated using the fundamentals of noise control that we have learned so far. So, we will take an overview first of the noise in the mechanical system, what are the common sources of these noises in the mechanical system, what are the factors that affect them, and what are the key mechanisms by which these noise are generated in the various mechanical systems. So, the noise in mechanical systems, so you know that noise is the unwanted or the harmful sounds produced by the machinery and the equipment while they are operating. So, what are the various causes? Essentially, because if it is a mechanical device, it is made up of some kind of parts which are rotating or moving with respect to each other. Okay, that is what any mechanical component or any mechanical system basically is, the components doing some kind of motion, sliding, contacting or meshing together. So, these moving parts, they can create noise, especially when they are colliding together. They can create a sharp impact which can again produce noise. The vibration of the various components, the plates, etc., they can create noise. Then the fluid flow, some of the mechanical systems might use the flow of air or the flow of water or coolants, could be coolants, it could be some kind of gases, refrigerants, etc., which might be flowing through various kind of pipe waves, and this fluid flow then also creates the noise. And then the same air flow, sometimes, for example, most of the fan based equipment, they have a lot of air flow or various kind of aerodynamic devices, they would have this air flow, and at certain higher operating speeds the flow becomes turbulent in nature, and this turbulence can also create the noise. So, as a summary, these are the key things which can create the noise in the mechanical systems. And obviously, the major mechanical systems are the industrial, the machineries employed in the industrial work, in the HVAC systems, in the transportation systems, construction systems, all of this, they are able to create the noise because of these primary causes. Okay. So, let us first see what are the types of noise in the mechanical systems. We can classify the types of noise as structure borne noise, airborne noise and fluid borne noise. This is one type of classification. Here the classification is based on the pathway of sound transmission. So, how is the noise reaching from the source to the receiver? If you track down what is the pathway that the sound wave is taking for propagation or transmission from the source to the receiver, and accordingly you can classify it into these three categories. What is a structure borne noise? It is a noise that travels through the solid structures, typically originating from the mechanical vibrations within the system. So, what happens is that, see, essentially we, if human beings are the listeners, we essentially hear the sounds or the noise through the air, okay, because to the ear it will reach through the air. So, ultimately air would definitely be the pathway. So, how do you classify a structure borne noise? It is for those things where the noise is transmitting through the various kind of structures before propagating to the air. Okay. So, from the main source, it is taking a lot of structural paths to transmit, and from these structural paths finally it propagates into the air and reaches the listener. So, the structures become one of the important pathways in between the propagation of these sound waves. Okay. Then you have the airborne noise, which is directly from the source, the noise is propagating into the air and then reaching the listener. There is no in between structural paths that it is taking. Then we have the fluid borne noise. It is the noise due to the flow of the fluids, such as the pipes, the liquids and the gases that might be flowing through the pipes or the valves or various kind of ductways. So, let us see some common mechanical systems and their noise sources. So, in any kind of mechanical system you would have a rotating machinery. Okay. So, any kind of rotating machinery, such as rotating machineries in the turbines, compressors, flywheels, fans, etc. So, what is a major noise source here? Suppose in the rotating machinery you have some unbalance. Okay. So, because of some manufacturing defect or because of the machinery becoming old and the wear and tear happening in it, there would be some kind of mass unbalance. So, unbalance in the mass can result, and when the machine is, when that component is rotating due to this unbalance in the mass or the manufacturing defect which creates the unbalanced mass, there would be some specific noise that would be generated at the rotating frequency of the component, which would be very annoying. And the other way could be, one could be the mass imbalance. This is the mass imbalance, so unbalanced masses, which is creating the noise at the rotational frequency. Even the misalignment. So, usually what happens is these rotating machineries, they are aligned to the other parts of the machinery and they are fixed to the various shafts, and they are supposed to come in contact with the other part of the machinery. Suppose there is a fault in the design of the machinery, or there are some loose fixtures, the parts of the machineries are kept loose, or the machinery has gotten old and wear and tear has happened. So, because of this manufacturing defect or improper installation, or because of the wear and tear over time, sometimes the shafts, they can shift and they may not be properly aligned. So, maybe one shaft they had to be like this, but due to the misalignment, some shaft is like this, and the contacting components are then meshing together in the wrong way, and that is also creating severe amount of vibrations and noise. And then similarly, any other source of vibrations that might be happening in these rotating components, they can create the noise. What is the type of noise then created in such kind of rotating machinery? So, due to these phenomenon such as imbalance, misalignment and vibrations, the type of noise created is the vibration induced structure borne noise. It is usually a tonal noise at the specific frequency. This corresponds to the rotational frequency of that component, okay, corresponding to the rotational frequency. Then let us see another common mechanical part, which is an IC engine that is found in many kind of machinery, such as in the automobiles, in the industrial generators, etc. You find an IC engine. So, what happens here? What are the major noise sources in this case? First of all, within the internal combustion engine, you have the combustion of the fuel that is taking place. So, this combustion itself is an explosion, okay, it is an explosion of these combustible fuel and the release of energy, and this combustion process itself is a noisy process. So, combustion phenomenon can create noise. Then the release of the exhaust at a high rate. So, when the exhaust is releasing at a high rate, it can create the noise, and the engines are usually connected to the crankshaft, which convert the energy given by the engine into rotating motions. Okay. So, the crankshaft is used to convert the thermal energy of the combustion process into the rotational motion of the various machinery components, and this crankshaft movement itself is again a rotating machinery. It can create noise. The vibration of the structure containing the engine, etc., and its components can also create noise. Usually this is a low frequency noise. It is usually vibration induced, fluid induced, and tones plus harmonics both are there. So, here suppose the engine components are rotating, for example here, okay. If the engine components, they are vibrating, this will create a vibration induced noise. The crankshaft movement will also create a vibration induced noise, whereas the process of combustion, it is going to create a fluid induced noise. it's mainly the flow of the gases, and the exhaust also will create mostly a fluid induced noise. Okay. And the noise is created both at the tonal noise plus is higher harmonics are created typically when the engine is operating. Then you have some other common systems such as the pump and the compressor. So, what is the noise source in a pump? Because pump is used, hydraulic pumps and compressors, they usually are used sort of drive the fluids in some specific format. Okay? The fluids, high pressurized fluids are driven through different kind of pathways in these pumps and compressors. So, obviously, fluid flow is definitely one kind of a noise, and usually in the fluid flow you have a phenomenon called as cavitation that happens. Then the turbulence during the fluid flow can also create the noise, and other than the cavitations and the turbulence due to the flow of the fluids, you also have that whatever is the motor of this pump and the compressor, it is vibrating, and this is also creating noise. So, both fluid borne and airborne noise is there. The fluid borne is due to the flow of these pressurized fluids in this case due to cavitation and turbulence, and the structure borne noise is due to the motor systems. Okay. In this kind of machinery, some examples of this machinery is like the hydraulic pumps, the refrigeration compressors, etc. Let us see now, even gear system is a very common mechanical component in various machineries. This is a very important subcomponent. It is found in various kind of automotive transmissions, in the industrial gearboxes of various kind of rotating machineries and plants. So, in fact, gear system is a very common component in almost every mechanical machinery. You find some kind of gear system where you have any machinery with rotational power, any machinery where you have to transmit the rotational power, you will have a gear that would be present to convert and transmit that rotational power. And what are the common noise sources in this? The meshing of the gear is like an impact between two bodies. The two bodies, they are coming together, they are meshing and they are sort of running over one another. So, whenever what happens, whenever two solid bodies they come and they collide and they slide over one another, what could be the typical thing that could happen? One could be the friction forces would be there. The other could be the impact and the collision. So, the gear meshing process could involve the impact, it could also involve frictional when the two gears they are meshing together, then the backlash that happens between the gears, and the gears they are connected to the shafts if there is any misalignment in the shaft because of the reasons already discussed. Then also that can create noise because of the misalignment, the meshing is improper, and when the gears are moving together, they are facing a lot of resistance while meshing together and running over each other, and that is creating a lot of noise. Then if suppose the lubrication is not there, then also a lot of friction is there, and that because of the lot of friction and surface roughness, lack of lubrication, again the noise is created. Okay. So, what is the typical noise we observe here? We observe a typical gear whine which could be sharp tonal noise. The clicking or clunking sounds could be observed, and most of them they are going as airborne sounds. Then we also have hydraulic systems. In the hydraulic system, what happens is, for example, in the construction machineries, hydraulic systems are used, various kind of aircraft hydraulic systems, even in the presses you have hydraulic presses used in the industrial machineries. So, what you have is that you have the pressure fluctuations, you have cavitations and vibration in the pipes, because ultimately hydraulic system uses fluids for deriving the motion. So, the fluid is flowing through the pipelines. So, because of the pressurized fluid is going through the pipes. So, there could be pressure fluctuations in the fluid, the hydraulic fluid, okay, the fluid that is there, the pressure fluctuations could be there, the cavitations could also result from the fluid, and then the pipe carrying this pressurized fluid could vibrate in response. So, both the vibrations which is going to create vibration induced noise, whereas the pressure fluctuations and the cavitations inside the fluid will then create a fluid borne noise. Okay. like this, and this will the pipe vibration is then going to create a structure borne noise. So, you see both ways, both these type of noise is generated. Then fans and blowers are once again an important kind of mechanical system and subsystems. So, here again this is it involves a lot of air flow. The air flows at different kind of operating speeds, and you have your turbulence in the air. So, this turbulence can create noise, and then just the process of the blades cutting the fluid. So, the blades are moving and the air is flowing through these fan blades. So, it seems like when they are rotating, the blades, they are cutting the air, and this process is creating the noise, and it is created at the blade pass frequency. What is it? It is the frequency at which the blades of the fan, they are cutting the fluid, and it is given by the RPM into the number of blades divided by 60. So, it is simply the revolutions per minute of the fan multiplied by the number of blades, because per revolution those many blades of the fan, they are cutting the fluid. So, per revolution those many times the fluid is getting cut. So, N RPM into NB by 60, or simply the revolutions per second of the fan multiplied by the number of blades, because per revolution that many times the fluid is getting cut. This gives you the blade pass frequency. Then there are various other aerodynamic interactions, where the fluid is interacting with the machinery component. All of this is creating noise in these fans and blowers. Some examples of the systems containing fans and blowers are the HVAC systems, the cooling towers, etc. And what is the noise generated? So, the turbulence phenomenon typically creates a broadband noise, okay, and the blade rotation creates the tonal noise. So, you have a combination of both broadband component because of the turbulence, and because of the process of the blade cutting, it creates the tonal noise. At what tone? It creates it at the blade pass frequency. That becomes the tonal noises frequency, okay. At this frequency the tonal noise is created, and all these are airborne. Okay, so as you saw, in most of these mechanical systems, it is a complex phenomenon. You can't say that the noise is only created due to this phenomenon and this is the type of noise. You see that in most of the mechanical machineries, you have a lot of components, and because of the interaction between these components, you have the fluid borne noise, structure borne noise, airborne noise, tonal as well as broadband component due to the different sources. So, it is a combination of lot of phenomenon that happens in these mechanical systems. What are the major factors which affect the noise in these mechanical systems? So, first of all, and the most important one is the mechanical design, and that is why noise control is very important in the field of mechanical design. So, if the design is improper, it is going to lead to noise. So, just to put it in very simple way, simplified way would be that if any machinery is operating, the lesser the friction, the less resistance there is to the functioning of the machinery, the lesser would be the noise. If the machine is able to function and work very smoothly and faces very less resistance to its operation, then the noise is going to be low. But if you increase the resistance to the operation of machinery, so instead of having a very smooth operation, now the machinery, the operation is no longer smooth. Either it could be due to a misalignment in the shafts or the imbalance of the mass, or it could be due to the surface roughness which is creating friction, due to the wear and tear and lot of other issues, and improper lubrication which is sort of hampering the smooth functioning of the machinery, then the machinery is going to get noisy. So, here the noise from the machinery is very much correlated with how good the condition of the machinery is. So, if the machinery is in a good condition and has been properly installed, it will make the least noise. So, in the design part, you have the misalignments of the various shafts, gears, the imbalance in the mass. This also creates the noise, because then when they are moving, there is an misalignment is going to create some additional forces, unbalanced forces, which will lead to mechanical wear and tear as well as vibrations, and that will increase the noise. Even the unbalancing will create an additional force or an unbalanced force, which is usually the centrifugal force during the rotation, and this again will cause vibrations and ultimately lead to noise. Then you have the material properties, what kind of material you are selecting, because some materials when they collide with each other or when they slide over each other, they are essentially more noisy compared to the sliding of some other materials. So, the stiffness of the material then becomes an important characteristic, and the density. The rigid materials, they transmit more vibrations compared to the softer materials. Okay. So, rigid materials, they transmit more vibrations, whereas softer materials, they transmit less vibrations. They in fact absorb the vibrations along the pathway. So, the stiffness of the material is important. If the stiffness you can reduce, then maybe you can create more softer materials that can lead to lower vibrations and lower noise. Then density also, denser materials, they tend to block the noise and act as sound barriers, whereas lighter materials will vibrate more and emit more noise. So, basically stiffness essentially has to be reduced and the density has to be increased for lowering down the noise. Okay. So, we would favor stiffness as low and high density material for noise control. Then the operating condition also matters. For example, what are the speed conditions, the load and the maintenance conditions. So, if suppose you have some machineries which are operating at much higher speeds, then higher speed corresponds to more kind of aerodynamic noise, more kind of turbulence, more airflow, and hence more noise. And then suppose some machineries, they are heavy duty machineries, they involve heavy forces and heavy loads, they will also create more noise. Then the maintenance condition, obviously dirty clogged components, they will disrupt the airflow in the HVAC appliance, create more friction in the rotating parts. All of this is going to boil down to creating more noise. Even the lack of lubrication, which will increase the friction between the moving parts, which will again lead to more vibration and noise. The wear and tear of the components such as in the bearings, the belts or the gears, it is going to generate more noise again because of creating misalignment, imbalance in the masses or in the increase of friction. Okay, so the machinery needs to be in a good operating condition. If the operating condition is bad or the maintenance of the machinery is bad, then obviously poor maintenance, essentially poor maintenance would mean more noise, will ultimately create more noise. So, proper maintenance is required for the machinery. What are some other factors? You have the environmental conditions. For example, what is the surroundings of the machinery, whether the machinery is enclosed by some barrier materials or it is out in the open or it is out in some reflecting factory floor, that is all going to contribute to how fast the noise is going to transmit and be perceived by the human beings. You have various damping materials that could be used to absorb the vibrations and reduce the noise, such as rubber pads, acoustic foams, vibration damping and compounds. So, if you sort of use these kind of materials around the machinery, then noise would be less for the same machinery. Similarly, if you use some good soundproofing barriers and enclosures, that would also bring down the noise of the machinery. Okay, so some of the key mechanisms by which noise is generated in the machinery. Some of the primary mechanisms of noise generation is, first of all, obviously vibration. The vibration creates noise which is essentially the oscillation of the structural components of the machinery. Then impact, which is when the structures, they are colliding together, and this sudden collision between two solid structure is creating a sudden blast of acoustic waves or some sudden change in the acoustic pressure. Then the flow of the fluid flow creates turbulence and various kind of pressure alterations in the fluid, which again leads to noise. So, these are the mechanisms in which the noise is being generated. Then we have the fluid structure interaction, where the fluid is interacting with the solid boundaries and it is sort of there is an acoustic coupling. Okay. So, what is happening is that the fluid is flowing and then there are some obstructions in the pathway. So, it collides with the structure and sets the structure into motion, and then the structure starts radiating sound. So, now here what is happening, the fluid is sort of exciting the structure and the excited structure is then radiating the sound. So, that is the fluid structure interaction. So, why do we need to study these key mechanisms? We need to study them so that we can understand what are the ways in which the noise is being generated, and this will help us in deciding what paths we can take, what mechanisms we can use. So, we need it because based on that we can decide what is the noise control strategy we have to use, and what would be the location where we can apply that measure, what would be the extent and operational requirement for that noise control measure. So, definitely how noise is created and how the noise is being transmitted is very important, so that we can decide the correct noise control treatment. So, let us just study the first case and then we can close the lecture. So, the first case is the vibration induced noise. What is vibration? It is some kind of oscillatory motion of a mechanical component around its equilibrium position. So, in our lectures on acoustic fundamentals, we have seen that how vibrating structures, they essentially set the surrounding fluid particles into oscillatory motion, and then via these longitudinal oscillations, the pressure fluctuations they carry through as noise. Okay? So, the structure vibrates, causes the surrounding air particles to oscillate and generates the sound waves, and the frequency and the amplitude of the vibration determines what would be the frequency and the amplitude of the noise. Okay? And then, so not just this, we also have additional phenomenon known as the sound radiation. All of this we have already covered in the acoustic fundamentals. So, just a quick recap, that the extended large plates and the extended plates, they can radiate the sounds and transfer the energy to the air and generate more airborne noise. And what are some of the major causes in the mechanical systems? We have the imbalance that happens, and then we have resonance, which means that suppose the natural frequency, if the operational frequency matches with the natural frequency of the system, then the structure is set into resonance, which leads to a very high vibration and much higher level of noise. So, the operational frequency should not be equal to obviously the natural frequency, it should be as far away from the natural frequency, so that to eliminate resonance phenomenon. Okay. So, what are the common sources of vibration induced noise? We have the rotating machinery such as engine, motors and pumps. Then we have the gearboxes, which is the gear meshing which is causing these vibrations. Then the HVAC systems, the compressors, fans, air conditioning units, the various kind of structural vibrations. So, basically essentially if you have a mechanical system, definitely there would be more than one sources of vibration induced noise. And what could be the control measures? Dynamic balancing you can do. So, you can balance the mass, you can fix the alignment, you can use vibration isolators, and you can apply proper maintenance and lubrication. All of this could help in controlling the vibration induced noise. So, with this I would like to close the lecture. Thank you for listening.